Okay, there's part 2a4c3k8. Line 22f119c, f1fa19c3k8. Crystal lattice body-centered cubic Miller tetragonal UFO 5G Wow Seti. Here's the Wow Seti alien radio signal that brought up the data. August 4th is when I started working on it. Today's August 27th, 2012. So the formation of polyatomic and molecular ions cross-reference boron oxide. So we're going to look at the boron oxide cross-referencing. So up comes the crystal structures. A quote from Wikipedia. This was from a redirection from crystal lattice. In mineralogy and crystallography, crystal structure is a unique arrangement of atoms or molecules in a crystalline liquid or solid. A crystal structure is composed of a pattern, a set of atoms arranged in a particular way, and a lattice exhibiting long-range order and symmetry. Patterns are located upon the points of a lattice, which is an array of points repeating periodically in 3 dimensions. The points can be thought of as forming identical tiny boxes, called unit cells, that fill the space of the lattice. The lengths of the edges of a unit cell and the angles between them are called the lattice parameters. The symmetry properties of the crystal are embodied in this space group. A crystal structure and symmetry play a role in determining many of its physical properties, such as cleavage, electronic band structure, and optical transparency. Unit cell, the crystal structure of a material or the arrangement of atoms within a given type of crystal structure, can be described in terms of its unit cell. The unit cell is a small box containing one or more atoms, a spatial arrangement of atoms. The unit cells stacked in 3-dimensional space describe the bulk arrangement of atoms of the crystal. The crystal structure has a 3-dimensional shape. The unit cell is given by its lattice parameters, which are the length of the cell edges and the angles between them, while the positions of the atoms inside the unit cell are described by the set of atomic positons. Maybe I'm saying it wrong. X, I, Y, I, Z, I, measured from a lattice point. Simple cubic P, body-centered cubic I or L, face-centered cubic F. Within the unit cell is the asymmetric unit, the smallest unit. The crystal can be divided into using the crystallographic symmetry operations of the space group. The asymmetric unit is also what is generally solved when solving a structure of a molecule or protein by X-ray crystallography. Miller indices, and there's the different calculations that it looks like. Quotes from Wiki. Planes with different Miller indices in cubic crystals. Vectors in atomic planes in a crystal lattice can be described by a 3-value Miller index notation. LMN. The LMN and directional indices are separated by 90 degrees. And are thus orthogonal. In fact, the L component is mutually perpendicular to the M and N indices. The Miller indices for a plane are integers with no common factors. Negative indices are indicated with horizontal bars, as in 1, 2, 3. In an orthogonal coordinate system, the Miller indices of a plane are the Cartesian components of a vector normal to the plane. Considering only LMN planes intersecting one or more lattice points, the lattice planes, the perpendicular distance d between adjacent lattice planes is related to the shortest reciprocal lattice vector orthogonal to the planes by the formula d equals 2 pi. I don't know how to say that. Quote Wiki. Lattice systems. These lattice systems are a grouping of crystal structures according to the actual system used to describe their lattice. Each lattice system consists of a set of 3 axes in a particular geometrical arrangement. There are several lattice systems. They are similar to, but not quite the same as, the 7 crystal systems and 6 crystal families. The 14 Bravais lattices, the 7 lattice systems. So there's triclinic, monoclinic, which is base-centered, orthohomic, face-centered, body-centered, face-centered. We're looking at the body-centered one because it's got the thing in the middle. Rhombohedral, tetragonal, that's another one, that's the base of the core. Hexagonal would be the rear of it. And the cubic is something to do with something. Quote wiki, the simplest and most symmetric, the cubic or isometric system has the symmetry of a cube. That is, it exhibits 4 threefold rotational axes oriented at 109.5 degrees. The tetrahedral angle with respect to each other. These threefold axes lie along the body diagonals of the cube. The other 6 lattice systems are hexagonal, tetragonal, rhombohedral, often confused with the trigonal crystal system, orthorhombic, monoclinic, and triclinic. August 27th. I've split the rest of the data into the next video, line 22f1fa19c3k8. Keyword is atomic coordination, because I didn't want the video to be too long, okay? So you have to go to the next one to see the rest of what this has to say.